Here's question 26 from the 2014 exam, and as with all questions you have to read the words pretty carefully. So we've got one about a spacecraft which is performing a sort of comet, studied some comet, it collected gravimetric data, expect this model to fit. Okay, so what the important information in that lot is, that's the equation we're expecting our data to fit. Over here in this table is the data, and this is a picture of it. Okay. From the data, determine the value of the constant A, that's in the equation, the A on the top, to the nearest million, and constant B, to the nearest whole number. So A to the nearest million, B to the nearest whole number. Okay, so we've got lots of data here. We have an equation here. We are given from our thing what G, from the data, we're told what G and D are. So we've just got A and B to find out. We have two unknown variables. Well, we can just do simultaneous equations. We've got lots of points to choose here. I don't think it's going to matter. We should get the same answer each one we do. The note says you do not need to use all the data. So we only have to choose 2 points, get the D and the G from those 2 points, put it into this equation, and then using simultaneous equations find what the missing 2 variables are. We do that, we've got 2 missing variables. If we get ourselves 2 equations and 2 unknowns, we'll just solve. And these numbers look properly ugly. They're not going to give us nice, easy, solvable equations if we put them into here. So I'm going to use the calculator to do that for me. You could slog it out otherwise, put in 18, 73 and 14 for one of your equations, but really it's going to be terribly messy, and we've got a calculator with us, so let's make this a calculator activity. Okay, first thing I'll do is I'll just write down on the page, because you can't just do it on your calculator, you've got to write down to the examiner what it is you're doing. So I'll just write down very clearly what I'm doing, and then I'll actually do it on the calculator. So I have the first point I'll use the first one, is the point, the X value is 6367 and 3 points. And I'll use another one. It doesn't really matter which one, but I'll use the one in the middle, the 18, 73 and 14. Okay. Now then I will just explain what I'm doing. I'm going to use calculator, calculate, to solve simultaneous equations, and I'll just write down what those equations are. I'll get my letters around the right way. That's normally my X and my Y. We've got a G, the D, and then the G. Okay, so that's the D and then the G. Just making it clear in my head what's going on. Okay, so from the first one we were going to get 3, because that's the G value, equals A, which I don't know, divided by D, which I do, 6367 plus B squared, and we also have 14 equals A over 1873 plus B squared. So those are my 2 equations, just using the equation I've got and 2 of the piece of data. You could clearly do this using any of the bit of data that you wanted. Once we've put it down to that, now we can just go over to the calculator and get the calculator to do it. So here's my main screen. I want to use the simultaneous equations part of that on this calculator. This is a Casio class bed. I go to the keyboard and I look for that symbol, which is that one there, and that gives me my write your 2 equations and then the variables looking at. Now let's type in the first one, which is that 3 equals. I'm going to use the letters, so I'll go to the ABCs. I need A divided by, now I need to put that lot all squared. I guess we'll be careful with your brackets. I'm going to have to do it in 2 brackets. And inside the first one, I put the 6, 3, 6, oops, 6, 3, 6, 7 plus B. Close that first bracket off, then I have to put that to the power 2 and close that off again. Yep. And then this, if I hadn't put that second set of bracket in, it would square the whole lot. So you know, make sure you only want to square the bottom. I don't want to square the A on top as well. So that's why I've been very careful with my bracketing. Second one is going to be 14 equals, there's the A, and the 2 brackets, oops, not that way around, that way around, 1873 plus B, square that bit, close the brackets off, and then I'm going to solve that for, in this little box here you put what you're solving for, and I'm solving for A, comma, A and B. And I just check my numbers, and that looks okay. Right, let's get to do it, Exi. And I get my solutions. The first thing you have to do when you get these solutions is be terribly careful. I'm looking at here, I can see there's 1, there's A and there's B. But I'm also seeing an arrow here on the right, which means there's more solutions. It's going to be more than 1 solution. So let me just, oh, here it comes. That's the whole of the first lot. I'm keeping going. I've got 2 solutions here. Second one, B is almost exactly 2000, and A is a great big number. First one, I've got B is a negative number, and A is a positive. Okay, we've got A is positive both times, B is negative or positive. We will have to look at the situation to decide which one of those is going to be useful. Let's just go back to the picture. Okay. You have to use a little bit of your knowledge of a truncus, which this is, you know, 1 over x squared graph. I'll just show you a very quick picture. 1 over x squared looks like that. And you can see from our diagram here that our whole thing has been translated left. That means, because you know the asymptote clearly isn't to this side of the g-axis, because we've gone to the left, everything must be positive in the bracket here. So we can't have that negative solution, because if you were negative, it means you'd have a translation to the right, and our graph would look different. Because we've gone to, I'll just say that again, because we've gone to the left with our picture, and you can see that clearly our original 1 over x squared has been moved to the left, it means everything must be positive in here. So now going back to our solutions, we have to get the positive one. So the first one was the negative. We don't want the negative 3295 stuff. We want the positive solutions. So let's write them down. Oops. Right, from this we get A equals 210.35806.5. B equals 2000.314, rounded off. And we're almost there. Just remembering, again, you have to read the words carefully. Define the value to the nearest million for A, and B to the nearest whole number. So, to the nearest million, right, millions go 1, 2, 3, 4, 5, 6. That's millions, so A equals 210 to the nearest million will be just 210 million, that's rounding off, and b to the nearest whole number is 2000. Okay. A equals that. To the nearest million. To the nearest whole number. Just checking again that I've done everything we need to do in the question on the value of the constant a to the nearest million, b to the nearest whole number. Right, I think that's that. This is definitely a case when you get numbers like this, I think the calculator is a very, very useful companion. Okay, I will stop just there.